All right. Hey, everybody. Welcome to wasmCloud Wednesday for Wednesday, October 22nd. We've got a pretty exciting demo to start the call from Corey, who's going to be demoing wasmCP, which we talked about in the call a little bit over the past couple weeks. But it's a WebAssembly component development kit for the model context protocol. Corey, I don't actually know if you did an introduction the other day. I know Ian did right at the start of the call. Would you like to start by maybe just doing a little quick introduction for yourself, and then, I won't over prescribe. You can go right on to the demo.
Yeah, absolutely. Right. So Ian and I were previous coworkers at Extend, a startup that been around. I think it's been like 5 years now or so. Or I mean, we spent 5 years there. I was the founding DevOps engineer, and basically spent the last 4 years basically building out their infrastructure as code serverless platform. And then Ian and I had a harebrained idea related to AI, and a couple months later, here we are.
Right on. Yeah, awesome. Well, excited to see it. I think you should be able to share.
Yeah, I am. I had to go through and make sure I could actually. Hello? All right. Am I actually sharing my screen? The typical start of
Yeah.
a demo.
Well, I can see VS Code and a
Cool.
Wasm Cloud.
Yeah, perfect. Yeah, so WasmCP, like we were saying, just a uh, aiming to be a framework for building MCP um, tooling, resources, prompts, etc. And so the idea here is we'll basically starting from scratch, essentially. So we will scaffold out a new tool. Um, right now we've got it's Rust, Python, TypeScript that are working. All right, so a bunch of templates quickly can scaffold out the tool. Hopefully this works. Sweet. All right. So in demo, um, that's the essentially the name of the tool. Um, provides a basically out of the box set of tooling that you can use just sort of as an example and reference point. So you can see here, a couple of tools: add, subtract. Um, we can, if we copy. Going to do my best to use wash for all of this. Right. So builds with wash, also just builds with all of the normal sort of like Rust tooling. Um, produces the binary with our tooling in it. And then we've got a compose function that basically wraps a lot of it in our our framework, essentially, like a lot of the related tooling to handle all of the MCP related stuff. So right, then produces the final binary. You can run it with wasmTime, spin, or wash. Um, and I've got some uh, a helper tool I wrote to start a lot of the wash stuff up. All right, cool. So should now be running. I believe I tried to get some of this stuff done ahead of time. Right, so you can see here's our demo demo MCP server, a couple of tools. Can can call as normal. prove it actually works. Cool, right? So calls our add tool. Away we go. So then if we come back, you know, this is pre-canned stuff I added just to not spend too much time writing code. Uh, Tools. That's all right. Right. So anyway, had some pre-canned, adding two more tools, squaring numbers, square root. So we can go back, do another build, compose. Already exists. Uh, Now, in theory, if it goes as planned, if we reconnect, you can now see we have four tools. So we've got now square root, and that's essentially the local development flow. I mean, it's as easy as defining your basically your business logic, input schema, options, etc., and then the like just the code. Um, so you're basically not responsible for pretty much anything outside of, this is this is what I want to make go. Um, in addition to building and running this stuff locally, um, we just pushed some stuff, and I don't think I have anything published that will technically work. We can give it a shot though. But basically, can support again either um, local paths. So here's what's um, helps to spell things correctly. Um, have some also like helper functionality built into the tooling. So rather than necessarily like having to copy around a bunch of paths or OCI references, etc., have some basically like just aliasing that you can use. So you can see here I've got a couple of um, aliases here pointing to various paths. So this can be a local path. It can be an OCI reference, um, um, etc. So then that way you can, we'll see if this works. If not, we'll call it the demo gods. Yeah. So what I thought. We'll see if we can get something published real quick. Give this one more shot, and then otherwise we'll just have to take it on faith. Yeah. Anyway, like I said, we pushed a bunch of new. We sort of finalized a lot of the WIT and the common packages that we built have not been updated yet. But essentially, again, you can essentially compose a number of items together from these local paths. So you can essentially do, say, like again, it's the compose my local my local file, the like OCI reference of, like, here's my published, commonly available packages, etc. Um, and basically get the resulting MCP server with those tools. Given that the pre-compose stuff is not working, let me grab. We will just outline it here. So one of the other we've been calling it middleware, but that's not necessarily its correct naming. I think we're calling them like composed tools. But one of the more interesting patterns that we've put together that this sort of allows for is, in addition to being able to call those tools directly, um, you can also build out these middleware patterns where, for example, I've been using the Pythagorean theorem as a good example to sort of outline it, where in a given set of functionality that you can put together in an isolated component, in addition to the normal, like, handling a tool, you can see here, this sort of sits above the level of the tool that we put together for, say, like adding and subtracting, where this, when it receives a tool call, it can decide what it wants to do in terms of, if the tool request name is for, Pythagorean, it will handle the call. And then if not, it just hands it off down to the next component in the chain, which again is the when you compose these together, you imagine it just goes like left to right as the call flows um, through the various tooling. And so in this case, when it's like, all right, this is a tool I care about. Uh, where is the code? Here we go. Uh, Typical parsing the arguments, but you can see here we can actually call downstream tools. So in this case, it's the, like, cool, I need to square the number. So it calls downstream um, to the square tool, um, gets its response, stores it, calls the square root tool, or sorry, right, squares both numbers, gets the results from those tools, calls the square root tool, gets its response, and then essentially then returns its response, giving you the hypotenuse. Which means that you can basically you can build out these tools in such a way that you could call the square tool directly from your server, or you can say then like use these composed tools to essentially like abstract functionality. To where we could get it set up in such a way that it just doesn't expose, say, the square or square root tool, and only shows the Pythagorean theorem tool to the AI client. So it's a good way to again like build out functionality in a composed, reusable way, and then sort of allowing you to decide how much of that you do or do not want to expose to the AI. In that you could pre-compose, say, this as a component on its own, and publish that alongside of the again sort of like more lower level tools. I think if given this is all on the, I don't actually know if this will build or not. What have I got in here? All right, we'll call it demo guides. But anyway, we wanted to show a bit more of this actually working end to end, but that's essentially it. So again, you can imagine that some of the power here is being able to say like write a tool once, and be able to reuse, reference it, etc., as needed in these MCP servers, to quickly build out tooling. Because one of the other patterns that we've been looking to play around with is you could imagine that you can almost dynamically on the fly compose a lot of this stuff, given that these are all just publish OCI artifacts, to sort of like quickly build out or test uh, functionality. And again, in such a way that you are essentially just responsible for writing your business code and business logic without necessarily needing to know anything about MCP, how to use it, stuff like that. Um, and again, we think it's, I mean, we're still sort of on the early days of this, but again, you can see here, imagine being able to build out a lot of these sort of like very useful functional tools to sort of like power AI applications. And with WebAssembly and this pattern, really sort of setting the bar for real-time AI applications that are likely to have a lot of these you know latency sensitive sort of requirements. So yeah, I mean that's largely it. Happy to sort of like step through or go into more detail as folks would like. I know I sort of ran through a lot of that, uh, but yeah, that is largely it. It's just a very quick and easy way to start getting up and running with MCP on WebAssembly, on pretty much any runtime. Uh, I'm trying to remember because yeah, have this working with. I mean, it works Wasmtime. You can see that most of the like everything that I've been doing has been with Wash, but also have it working via Cosmonic control. And I don't remember my own tooling. That was it deployed. Was I using for the that's it. Okay. Anyway, does work via, I think it can actually work. Let's see if, fucking doc's not running. Good times. Anyway, while I run through this, yeah, if there's any questions, etc. But
Yeah,
Supervisor
no.
runs basically on pretty much any WASM you know supported platform at this point.
Yeah, Corey, I saw that you or like in the WIT, I guess it was just like a single export of an interface.
Yep.
What what happens, and we were talking about it a little bit in the side chat, but how does that actually run in all the different runtime, like Wasmtime, Cosmonic control, if this is like a totally custom interface?
So this interface, right? So I mean, this is essentially the WIT that you're required to write, and that this is like tools, and we've got um, resources working as well. But it's basically that. Like if you wanted to use resources, you import resources. If you want to run tools, you import tools. Um, and then all of our WIT stuff is then essentially what um, um, wraps wraps all of that and handles all of the exposure for say um, these various runtimes. So you can see we've got the various protocol stuff where I mean there's the MCP related stuff and typing. Where's our uh, and you can see this is it where like we sort of import and export handlers. This handles the middleware chain, which is what allows sort of the composition where um, each of our like the wasmCP compose functionality is essentially what goes through identifies whether you've written like the middleware, which is again the like if you wanted to intercept or compose tooling pattern, imports and exports this. If it's a tool, it just exports that tool handler and detects that and wraps it to eventually get to the things like handling the streams, incoming incoming handler, stuff like that. If
Okay.
if that
And
makes sense.
yeah, I think that makes sense. So yeah, you have like a whole representation of the MCP protocol and like types and stuff in WIT. And then I assume there's like a WASI HTTP component that you've got somewhere so that like Wasmtime can just run it using what is it, the streamable HTTP transport, or are you doing it all over like standard in, standard out?
No, I mean this is absolutely using streams and WASI HTTP.
You want me
Um,
to talk a little bit about this part?
yeah, go for it.
For sure. Um, I could share for a second too, just to talk over that part of it.
Yeah, go for it.
Am I allowed to share?
Uh-oh. You should be able to.
Okay, I think it's mine. I've got it join.
If not, I can always
Don't do it, Liam. Don't do it.
Wasn't
Um,
me.
shoot. Corey, I feel like I had another question. Hmm. Darn it. Well, wasn't fast enough.
hold on. I think I just granted Ian permission to share.
Nice.
Yeah.
Good. You're gonna see my browser.
Yep, yep.
All right, cool. Also, I'm gonna Starbucks for those if I can do noises. Um, yeah, the idea with the WIT generally is that there are two packages that are published here. There's the protocol package and the server package. In the protocol package, this is what you are generally implementing, like Corey showed you, if you're implementing like an individual feature for a server, like tools, resources, and prompts. And that's because this package is, like you said, Brooks, like basically a direct like translation of the MCP protocol types painstakingly by hand in split screen here, so that if you want to implement a different kind of framework architecture using these types, you at least have this published, like just straight up, these are ripped from the MCP spec. So if you don't like how we've implemented the actual like underlying like framework idea here, you can do it yourself without having to like rewrite or copy and paste like all these 1,000 lines of types basically. And then the features here are the same thing. These are signatures that are essentially like from the methods in the MCP spec. And then this server package is essentially like the implementation layer. And so this is essentially what like Corey described is like wrapping the like business logic functionality that you implement into this like middleware handler chains. It works kind of like this idea called the framework called MIDI for Lambda, which is essentially that you can like for serverless architectures define basically the full functionality of your application middleware stack the whole way through. And so that's kind of the idea here. And then yeah, you'll notice Brooke, you asked about HTTP. Our transport world, the contract is just that it imports the handler. So we didn't want to encode like you just have to satisfy this transport contract via whatever transport types that you want to implement. So you can implement this with different versions of HTTP. You could implement a WebSockets transport. All the transport has to do is handle message framing, and then calling into the underlying stack. So where the HTTP is right here is actually in crates. So you saw we have one transport world, but we have two transport components. We have an HTTP transport component, which is targeting that it's including the transport world we just saw, and then it's including WASI HTTP proxy. So for example, if you had for the I don't need to say for example, for the standard IO transports, everything like this, it's similar except it's including WASI CLI command. So you can basically, if MCP decides to include a WebSockets transport, we can support that without really having to change the contract of our WIT, or supporting, as far as I understand it, like gRPCs for wasmCloud could be possible via a similar idea, I hope. Yeah, that's all I wanted to share about that.
Yeah, super cool. It's just cool to take a look at, how you guys have structured the WIT and kind of made it transport agnostic. That's really, really nice. You just like get you just get generated bindings from wasmCP and write your tool, right? I mean, that's kind of it.
Yeah,
Yeah,
and that's exactly it. And that's it. It's like you scaffold out a tool, and again, it's the like here's my business logic and here's my input schema, and away you go.
that's generally how the MCP server SDKs work, is that you just have to define like the tools, resource, and prompt you want, and the framework takes care of the rest. And this is essentially that same idea, but implemented like first class on components, like leveraging components on purpose, because it ends up with a type of architecture that you couldn't implement with like a normal SDK. Like Corey showed, I don't know if it actually worked all the way through, but you can compose on the fly, components. Different tools, resources, prompts are written in different languages, like as compose time together. You can also like save sets of them. Like if you were to squish Lego bricks together, I mean, you have one Lego brick you can just carry around and squish with other things. And also we support basically, the goal is to support the full MCP spec. And so right now we support a lot of cool features like SSE streams from, like in your tool call, you can send notifications via SSE to the client ahead of the final result. And this is also what allows for things like illicit tokens and stuff, which we're still in progress on an example of that works in a similar way. So yeah, it's like the idea is that this should be a first-class MCP SDK, but built on components. And it could end up being a really, really good SDK. And it's definitely fun right now.
Yeah, I mean, sorry, last thing, and then I'll stop monopolizing all the time. I could totally see like this being something like you could publish an MCP SDK that when you compile the with like the WASM32, WASI-P2 triple, then you get all the component bindings, and when you compile normally, you get like, or like to the native target, you can just get a Rust binary, and it just all works the same. Um, Maybe I don't know. It's
Like we,
but that's
I
great.
played around with that pattern, but it just wound up being one of those like things where it's like if you wanted to just use native Rust, you're almost better off just using the Rust. Was it like RMCP or whatever? Just the official Rust crate. Because
Yeah,
we've built wasmCP has an MCP serve because we're building out and playing around with implementing resources as like a like helper in one of those. Like you can imagine running wasmCP MCP serve and then that exposing all of the context necessary for Claude to use wasmCP to build out tooling or like how to use it, etc. Um, I kind of have it working, but there it was the like just use the Rust crate rather than trying to like make make the wit stuff work that way. But anyway,
pretty fair. Yeah, what folks have questions for Corey and Ian? I see Masood, you have a question. I can read it, or you can go for it if you want. Um,
I'm
yeah,
just saying that what version of spec is covered by the current version of WIT. Okay, thanks.
The previous the '03 March release, like I've tried that with a client that only supports it and it should work. Like the negotiation done by our transport component should like work with either the current release or the previous one. And then obviously I think there's another MCP release coming out next month in November. And so we're going to be supporting both in parallel,
Yeah, so,
trying to
so
make that work.
Ian, it could be useful in the either in the README or in the header of the, let's say, MCP WIT or something, mentioning that what version of the protocol, so users would know that what the version of the spec they're aligning to.
Yeah, that totally makes sense. We'll add that.
Thanks.
pretty cool. I feel like you guys probably have a fun ability to like adapt people forward to different versions of the MCP spec too, uh, feasibly. I know you said you're going to support both in parallel, which makes a lot of sense. But if there's like a break and change later,
Yeah, that's the idea. And I think that's what a lot of the frameworks try to straddle with varying degrees of success because it can get confusing when you see, oh, I can add this new field and then nothing happens when you do. So we'll see. But yeah, MCP is changing all the time. Like it's probably going to look very different a year from now than right now. And all the coolest features of MCP, like the real value proposition, is in the bidirectional, like dynamic activity that like interactions that basically clients are only just now starting to support. Things like elicitations and dynamic tool sets via list change notifications uh, are kind of I think what makes MCP cool. I don't think MCP would be as compelling if it was just a basic tool calling protocol. And I think a lot of MCP implementations right now basically assume that it's just that. And so a real goal here is that, in addition to, being able to like support the new specs is like, we want to be spec complete, at least in terms of what you can implement. Like this shouldn't be like something that you should be able to do anything with wasmCP that you can do with an official MCP SDK is the idea. Yeah, parity.
and to go back to the like to the upcoming spec and stuff like that, you can imagine that some of the flexibility in the way that we've built this pattern out is, I mean, you could have multiple components handling specific spec implementations, right? In one of those, like we could compose, three different sets of functionality targeting different specifications, and that there's so much power in that just from being able to just like be able to support multiple specs easily, compose them all together and abstract that from the user. And in the same way, like I've been playing around with some of the idea of like you could imagine doing almost like A/B testing between like component A and component B via the middleware pattern and routing between one or the other, etc. So there's certainly some other interesting ideas out there from sort of like what this sort of enables.
Not to mention just using WASI proposals and stuff, like the fact that you don't see like Redis in here, but you're going to be able to manage state via WASI KV that may be backed by Redis wherever you're deploying it and stuff. And that, like, by building on components, is that I think Liam had mentioned it in his recent video. It's just continuing the trend of platforms, of technology to push more of the weight into the platform. And so, you can just get this like one component and you can drop it into Cosmonic control, into wasmCloud, or into any other basically component runtime. And because it's just a binary that can run with wasmTime, which is the, basically embeddable component runtime. It should be, portable across all of them. And so if this doesn't work for you, trying it out on anything with wasmCloud or Cosmonic control, definitely reach out to us, because that's, it should. Um, yeah. Yeah. Any other questions or anything?
Speak now, forever hold your peace. All right.
Well,
Well, Corey, Ian, thank you guys so much for. Oh, I'm sorry. Do you want to do a little outro?
no,
Thank
you
you.
go for it. Sorry. Thank you.
Thank you guys for coming on and doing the demo and talking a little bit about the project. Like, it's always, I'm glad you were able to get it working on Wash. Very cool. And Cosmonic, that's awesome. But it's just always cool to see new like Wasm component use cases popping up, especially for some of the like, well, Wasm's already kind of bleeding edge, but some of the bleeding edge stuff like running MCP servers and like to see you guys just kind of crushing the Wasm val prop. It's really neat.
Yeah, but there's more like component SDKs like this. Like, I think that idea of a framework implemented via components is a pretty general, like, cool idea. And hopefully, especially with Wasm P3, there's going to be some really cool ideas implemented that way. I'm excited.
Yeah, all right. Well, I know that you guys dropped a little bit or a couple links like in the Zoom chat, but just for anybody who's looking for this, if you go to github.com/wasmCP, that's where the project is. And then looks like you guys have like most of your examples and well, like the whole thing in that wasmCP repo. So yeah, go check it out. Um, cool. Well, I guess I have a much shorter and less impressive and fun demo, but it is a cool concept that we're introducing that landed in Wash that folks I think are going to be pretty interested in seeing. And I guess it might even have a little integration with the Wasm CP, like standard IO transport option. So you all might like to see it anyway. So let me go ahead and share my screen. You only get demos today. Very about it. So one of the things that people have asked about for a little while in Wasm Cloud is a cron capability provider. You know, some long-running process that can call components like on a timed interval to like execute a job, you know, something once a day or once an hour or whatever. That's how, everybody knows how cron works probably. And it's such a small, simple piece of logic. Like it really should be able to be run as a component, like something that's like kicking off jobs on a certain interval. And something that we couldn't really do in Wasm Cloud until today is run components that are long running and have a longer life cycle than just like receive an HTTP request, hand back an HTTP response. Like all the components that ran in Wasm Cloud were short-lived, reactive. Now we actually have a notion in the workload API in the Wasm Cloud runtime, or in the well, I'm dubbing it Wash runtime now, but naming aside, we're just bad at it. That is called a service. And a service is not a reactive component, not one that, say, like HTTP counter here, receives an HTTP request and needs to hand back an HTTP response. Services are components that target the WASI CLI world, which in Rust, for example, just compiles straight from anything that is a binary target, like a main function. And so services are components that can be long running. They execute for the duration of their basically main function like a process. And then when they exit, they're done. Like you finish the thing. But that lets us, for the initial couple of examples, that lets us do pretty interesting things like a cron service. So these, I'll show you the workload setup in a second, but I have two WebAssembly components. First one is this cron service, which if I inspect it, this is actually live on the, oh, I didn't build it yet. Sad. Nope. It is in crates, watch runtime, tests, fixtures, cron service. So if we inspect, no, I have the wrong wash. Wit. Haha. If we inspect this component, then we know that it just exports WASI CLI run, and then has a couple of other imports, but has one import for a custom interface, wasmCloud example cron. So this component just runs the main, prints something to standard out, and then loops forever. Every second, it's going to call this function wasmCloud example cron invoke. Now, if you just tried to run this like straight up in Wasmtime, you do a Wasmtime run, then it'll fail to instantiate because it doesn't know what this import is. You're calling some import from the host that WASI or that Wasmtime doesn't know anything about. But I do have this cron component, and this implements the other side of that interface. So it implements this invoke function, and every time it's invoked, it just prints to standard error hello from the cron component. That's it. So the WIT is mega simple. We just have one interface cron. The service world imports it, and the component world exports it. So this is something that you could just compose directly together with WAC or the component tooling, and then run it, and it would work. But with Wash, we can actually compose these at runtime. So instead of whacking them together, we can run them separately, but in the same workload. And Wash's workload resolution will automatically allow this service to call the component. So this is the entire workload that I'm starting. I don't need to mess with volumes or host interfaces or any annotations really, but I just basically run the cron service. So this like WASI CLI component as a service. And then I run one component, which is the cron component Wasm. So if I run this test, that is this test, I actually capture all the standard out so that I can like make sure that it works and we can do it with an integration test. But it runs and then every second calls the cron component through that custom interface. And you can see the print out on standard error hello from the cron component. So we get that 4 times because I run the service and then I wait for 5 seconds and then I tear everything down. But what's so cool about this is that this is nope, not this one. This is a long running component targeting WASI CLI running in wasmCloud or running with Wash. I think that this is effectively the beginning of our ability to proof of concept like capability providers and extending custom functionality with the wasmCloud runtime. There are a couple interesting things that we have planned to support with this, like allowing service to run and open up sockets, and then having the components in a workload be able to reuse those sockets on their, because it's already open, the long running component can hold on to the socket or the connection pool. And then the reactive components, when they get an HTTP request that comes in or something, can just directly use that socket. Yeah, these are some of the things that we want to try and proof of concept with the service thing. So this just landed in main in the Wash repository, but it's the ability to put a service in a workload, and that's just any component that targets the WASI CLI world, which should be many binaries that you can compile from Rust or TinyGo or bringing another one like C, anything that just compiles to a regular binary that you just run. So yeah, this I think there's probably room for a more compelling example in the service area, but it is really neat to see this working. I hope to work on some of the socket support next because I think that'll cover some pretty interesting use cases for like replacing some of our more simple providers with components. Should make it a lot easier to run. Um, Let's see. I see some stuff in the chat. Yeah, Corey. LOL sob. Yeah, exactly. This would be a great way. Or Ian asked. So it would support MCP server behind the standard IO transport, which is done with WASI CLI. Exactly. Like if you're targeting WASI CLI, then you could run your MCP server as a service, and then I don't think we like pipe standard in, standard out um, to the component now, but still some more things to figure out there. Frank, you had a question? How to make sure this is always live? Like how to make sure that that service just continues to run? Maybe. I'll assume that. Um,
Yeah, no, that's exactly it.
okay.
I mean, if we're going to put a service there, we want to ensure that we have at least one replica or something that actually can respond to that the service is up and running.
Yeah, yeah. So the service is a key component of a workload. So you can define the maximum number of times that you want it to restart, but as long as the workload is running, then which just means like you started it, the service will execute for the entire lifetime of the workload. So if there's an issue, like you have an error, you exit with a non-zero exit code, we'll restart that component up to the number of times that you specify. But if the component exits too many times or you don't allow for a restart, then the workload will transition to an error state. Like we'll actually report that in the runtime. We'll say, hey, this workload failed. Like it couldn't run properly. Same thing for when you start the service initially. Like if you couldn't open up a socket to some remote endpoint, then we'll actually send you back a response that it failed to start. So there's probably, we I know that on the wasmCloud operator side, we'll have some integrations like for you to be able to see in your Kubernetes dashboards that the service is still running because the workload status is still healthy. Um, that would be the best way to like take action to make sure that it's always live, quote unquote. That makes sense, Frank? Did I answer your question?
Yes, thank you.
Cool. Um, yeah, I mean, Masood, you've said it boldly, but is service supposed to be the future of capability providers? I think is in terms of long running processes that the Wasm Cloud host can start. It is absolutely what we want it to be. Now, I'm not saying that the abstraction is perfect or we won't need to change things, but I think especially with WASI-P3, adding improvements for streaming, just generally nicer interfaces across the board, we and WASI TLS coming in, it's a really strong case for services to start replacing certain capability providers. Like if you just have a couple components that need to proxy some messages to NATs, I think that it's very doable to have a service that opens up a TCP socket to your NAT server or over TLS and then forwards WASI messaging messages onto the NATS bus. Like that feels completely doable, something that a component should be able to do. And so it'll be really cool to start. It'll be really cool to start seeing how feasible that is. As a general higher level note for the folks tuning in, I know that, well, this is a stance that maybe I've taken, so I hope people agree with me. I don't really want wasmCloud to be in the business of running like regular processes. I would rather focus, entirely on running WebAssembly. So I hope that we can start just running Wasm with services and in the workload API. And then if there's anything that still needs to be a provider for whatever reason, then that's orchestrated kind of separately, but next to the Wasm Cloud host.
I was thinking, for instance, from the point of view of having the OpenTelemetry that actually capturing those things and sending out as a as a service, right?
That sounds great. So like the yeah, all the components wouldn't have to worry about like exporting their metrics or logs or traces. They could just kind of they could open a connection, I guess, locally to the service and say, hey, here's all the stuff. You make sure that it gets to the right place, and then that service just is able to hold on to the connection to the actual like collector URL. I think unless we're already doing it automatically for you in Wasm Cloud, which I guess could be possible, then I mean that sounds like a great use case for it. Yeah, I kind of like a sidecar. I mean, that's kind of what this service is. It's basically just like a sidecar alongside the workload. Um, yeah, and Masood, just to answer your other question, will there be a so-called like provider SDK? Um, I hope not. I would prefer if we didn't have it, and only because my hope is that we could just run any generic thing that targets WASI CLI, and we don't have like special concepts that necessitate a provider SDK. Um, I hope to drive basically all the service implementation and like communication bits via WIT. And so maybe we'll have a special WIT interface for like advanced functionality, I guess, so to introspect or ask questions about the Wasm Cloud runtime or something. But honestly, I would prefer that we didn't have it, if at all possible.
Like host doesn't want to, or on the other side, service wouldn't require, some, let's say, some information from the host, let's say to instantiate. I mean, give you an example. Today we say that these are the components that are clients of this capability provider, right? So we kind of declare, are we saying that as long as they, let's say a client just implement the required width, they can communicate with the service, they really, we're not being restrictive, let's say, in terms of what is happening between a client and a provider.
Yeah, that's right. And it does change the relationship a little bit. Like like you said, now providers basically get told like you have these five components that you're linked to, and this is the information you need to call them. Um, but with a service, I think that it would be much more like one-to-one. Like one service is calling one component, or like specifically calling one component over a WIT interface. Um, because if you have five components that need the same service, you could run five workloads, or you can run a copy of that service for each component, and it's much more lightweight than running process, which is one of the reasons why providers need to be able to be multi-tenant, is because like running a binary per component just like starts to kill the value prop. It's, you know, we might need some additional runtime information in the service area. I'm not 100% sure, but yeah.
So,
Think what
so, so, something that I'm kind of thinking, and let's make it out loud, is that the service needs to call back, right? Especially if it's a long, and for that callback, it could be part of the service width, and the components that wish to use that service maybe need to implement that so the service knows how to get back to them.
yeah, I think that would be a decent um that would be, when I say decent, I'm not saying it's bad, but having like additional exports that are optional would be a good way to make that service API be more powerful without like requiring you to implement anything. If you just wanted to do the core, like the cron or the connector pattern. Yeah. Um, I think that'd be a nice way to do it. Um, if we need it. I definitely want to hold the bar high that, we should be able to work directly with WASI CLI and WASI HTTP components without anything special. And we definitely have that now, which is good.
That would be wonderful. Or rather, I assume that when you're saying that, like you're referring to a transport, because again, NATs could be another one, right?
Yeah. Yeah, yeah. All right. Well, hey, we ran right up to time with that one. Demos only wasn't Cloud Wednesday. Yeah, so services are still, pretty new. This is something that we've been playing with for quite a while, how we might want to support long-running components. And starting with WASI CLI seems like a great place. So I'm going to be working a little bit on like some more compelling examples of this. Workloads also support like WASI file system and most of the WASI CLI world, not quite WASI sockets, but in the concept of a workload, there's some pretty interesting things we can start to do when we think like mounting the same virtual file system between a service and a component, and having socket-based communication just over localhost or maybe even in process. There's some interesting stuff to tease out. So um, I think that, yeah, file system stuff would be cool for MCP stuff too. And the whole, oh God. Oh, well, I'm going to say this at risk of rabbit holing, but then immediately in the call, sorry. Same with like Claude skills, like being able to access the local file system or not, key. And that stuff is all really interesting. Um, okay, I said the cool thing, and then hopefully nerds type some people, and then we're just gonna leave. So thank you again, Ian and Corey, for coming on and demoing today. It was really awesome. Looking forward to see where the project um, ends up going. As you guys make progress, please feel free to let me know. You can always or let us know. You're welcome to come back and demo progress and stuff. Like if you get it working on Jco or what have you. All fun stuff. Sorry, Starling Monkey. Yeah.
Thank you.
I appreciate it.
All right, folks. Have a great rest of your Wasm Cloud Wednesday, and we'll see you next week.